Right, on the previous video I paused just so that I could get some graph paper set up, and so we need to be graphing as x goes from -3 all the way out to +4. So let's do exactly that. So on the x-axis we're doing a scale of 1 centimeter is 1 unit. So that means if I'm going from -3 to +4, that's a total of 1, 2, 3, 4, 5, 6, 7 units. In other words, 7 centimeters. So I need to plan my graph so that it is 7 centimeters wide. Furthermore, it says that in the a-axis, which is our vertical axis in this case, 1 centimeter represents 5 units. Now I'm going all the way from -13 up to +35. So +35, well that's 7 times 5, so that's going to be 7 centimeters because each centimeter is worth 5 units. So that's 7 centimeters above the x-axis, and -13, that's nearly 3 sets of 5 units below the x-axis, so I'm going to probably need to go down to -15. So I should plan maybe a total of 10 centimeters in the a direction, the vertical or y direction, going all the way from -15, -10, -5, 0, 5, 10, all the way up to 35. Alright, let's do this on the graph then. So I stuck it here at the end. So remember, we're planning our space to be 10 in height. So let's start then at -15, and then we're going each centimeter. And by the way, on IB-lined paper, 1 centimeter, you can always tell because it's got these darker lines to show the delineation between centimeters. And they end up being 5 tiny squares is 1 centimeter in both directions. So there's -5, here's 0. I guess that means that this is our x-axis. So I'm just going to draw across my x-axis here. Of course I should use a ruler. There's my x-axis. And let's continue going up. I'm at -0, 5, 10, 15, 20, 25, 30, 35, and well, okay, I guess I can finish at 40, but it fits okay. And then in my horizontal direction, remember that I'm starting at -3. So -2, -1, 0. So this must be my y-axis. Again, I should use the ruler. And then 1, 2, 3, 4. And that's as far as I need to go. I'll just throw in a couple of extras, but -3 to 4 is going to be sufficient. And I've still got my table open on the calculator, so let's just use that to fill in my coordinates. So when x is -3, my y value is -13. So -3 in the x direction and -13 in the y direction. There's my first point. And then I've got -2 is corresponding to +11. So -2 and +11, which is one of the 5 little squares between 10 and 15. -1 matches to 27. So -1, and then all the way up to 27. When I'm at 0, I'm at 35. Let's, oh, shouldn't have done that, sorry. I've got to redraw my y-axis now. In fact, it's not a y-axis, is it? It's an a-axis, because my dependent variable is area. Alright, let's keep going. When my x value is equal to 1, I can see that I'm at 35 again, and then I'm at 27 when I'm at 2, and when I get to 3, I'm at 11, and when I get to 4, I'm back into the negative region at -13. And we can see the symmetry of the graph. I just need to connect the points. So we'll have something looking like this. And it's going to go a little higher than these before coming down again. And that's the shape of the parabola. And you see that I've got endpoints. I'm only graphing it from -3 up to +4, no more. So it's not even bothering to put arrows to show that it extends further, because it said only from -3 to +4 in the question, right? Which, yeah, we only went from -3 to +4 as our given x values. Alright, part C. We need to write down the equation of the axis of symmetry. Now it says using your graph or otherwise. I suppose we could look at the graph and figure out the equation of symmetry. It is going to be exactly between 0 and 1, right in the middle. So it looks like it's going to be at 0.5 or 1/2. But it did say or otherwise, and I know that I don't really trust graphs because they're often not given to scale. So I would probably just prefer to calculate the axis of symmetry using my original function. I think I'm going to rewrite it first into standard form. So I've got my quadratic term first, then my linear term, and then my constant term. And so x then is equal to -b, which is -4, over 2a, 2 times -4. That's -4 over -8. The negatives cancel, and so your axis of symmetry has got equation x equals 1/2, just like we predicted by looking at the graph. And just to remind you that IB will always give 2 points for this kind of question. It will be 1 point for the x equals and 1 point for the value that x is equal to. But you must include the x equals, or you won't get full marks. Part I, we need to find one value of x for a rectangle whose area is 27 meters squared. Well, look, here's an area of 27. So one value of x must be -1. We also discovered that r was equal to 27, so there's another place where our area is 27. So either of these two x values would be a correct answer for part I. Just for the sake of argument, I'm going to write down the first one I saw, but you could have written down the second one, +2. We could have also used the graph to do this. On the graph, we can see that when the area is 27, I have a value there at -1 and another value there when x is equal to 2. Alright, part I says, using this value of x, write down the dimensions of the rectangle. The dimensions mean the length and the width. We know that our rectangle has got dimensions 7 minus 2x by 5 plus 2x. So let's substitute in my value x equals -1, so I can calculate what these are. So I've got 7 minus 2 times -1. That gives me 7 plus 2, or 9. And then I've got 5 plus 2 times -1. That equals 5 minus 2, which is 3. So my dimensions then are 9 by 3 meters. You might be interested, what would have happened if I had chosen the other x value of 2? What would have happened then? Well, I then have 5 plus 2 times 2. That would give me 9. And 7 minus 2 times 2, that would give me 3. I'd still have dimensions 9 by 3. Nothing would change. So, no matter which value of x you chose, the dimensions of the rectangle are 9 meters by 3 meters. On the same graph, I'm now in part D. On the same graph, draw the line with equation a equals 5x plus 30. So we've got a y-intercept of 30 and a slope of 5. Rise over run is 5. Alright, here we go then. On the graph, I have I'm just going to change the color so you can see the difference. Let's make it, say, red. And so I've got a y-intercept at 30. And then every time I go forward 1 unit, which is corresponding to 1 centimeter. Alright, I know you can't see my scale right now. There it is at the bottom. If I go forward 1 unit, 1 centimeter, I need to go up 5 units, which is also 1 centimeter. And so it must go there. Or if I go backwards 1 unit, then I've got to go down 5 units, which would be right there. And we can quickly draw our points, and then we can draw a line that goes through them, and we'll get something like this. Sorry, should use a ruler, of course. If you don't have a ruler, just use the edge of your calculator or your ID card or something. Right, almost done. Lastly it says, hence, or otherwise, so we've got a choice of methods here, solve the equation 4x squared plus x minus 5 is equal to 0. Well, there's one very easy solution I can see on the graph. I can see that this line I actually haven't explained something yet, sorry. Let's come back up to here again. So we're trying to find out where is the function, and remember our function was right here. That's the parabola. So I'm trying to find out where is my parabola. Where is it equal to the line? So one way I could do this is by bringing everything onto the same side of the equation. Why don't we bring everything over onto the right-hand side? So this negative 4x squared, when it moves to the right, will become a positive 4x squared. This positive 4x, when it moves to the right, will become a negative 4x. So I'll have a positive 5x with a negative 4x, giving me 1x. This positive 35, when it moves to the right, will become a negative 35. So positive 30 minus 35 will give me negative 5. What's left on the left? Just a 0. And you'll see then that that's why we're solving this equation. We're effectively trying to find out where is the parabola and the line, where do they intersect. So a good way of doing this then might be to add the equation of the line, which is 5x plus 30. Now at this moment, if I graphed, I wouldn't see what I want to see, because I haven't adjusted my window accordingly. I can see that based on my graph, I want my window, the x values, to go from negative 3 to positive 4, and I want my y values to go from, say, negative 15 to, say, positive 40. So let's adjust the window. Put our x max, I'm going to make it just a little bit bigger, negative 4 out to, say, positive 5. And then my y min, negative 15 out to positive 40. Now let's graph it and we should get a good picture. There's the parabola and there's the line. Where are these two things equal to one another? So I could say second calc intersect, that's option 5. What's my first curve? Yes, it's that quadratic that I entered into y1. What's my second curve? Yes, it's this line, 5x plus 30. And now it wants me to guess. So let's move the cursor close to the intersection point that we're trying to find first, which I guess is going to be, say, that one. We'll find out that this occurs when x is equal to 1. Well, you could actually read this off the graph, couldn't you? We could see that when x is 1, y 35, that's a point that exists on both the line and the parabola. So that's clearly one solution, is when x is equal to 1. Okay, remember, we're only looking for the x values here. So x is equal to 1. And now let's find the other possible x value. And so let's do it again. We're looking for now this other intersection. So second calc intersect, that's my first curve, that's my second curve, and now I need to guess. So we can either move the cursor over bit by bit, or I can just type in a guess. I think that maybe they happen to intersect around an x value of negative 2. Actually, it occurs when x is equal to negative 1.25. And I suppose another way I could have come up with these two values would be by using polyroot finder, polysimilt 2, on this equation. So I'll just show you that again. We'll say apps, polysimilt 2, and let's go into the polyroot finder, order 2, yes, and we'll put in a brand new equation of, well, I guess it's still a 4 is the x squared value, and then in front of the x value we've got a 1, and in front of the constant, or the constant term, is negative 5. And then we can say solve, and it'll give us the same two values. Now if you don't like it as a fraction, you can just press F to D, fractions convert to decimals, that button right there, and now it gives it in decimal form, negative 1.25 and 1. Before we leave the question, perhaps we should just consider whether both of these values are possible in the context of the problem. We know that when x is equal to negative 1, our dimensions work fine. We get dimensions of 9 by 3. Those are positive dimensions. That is allowed. What would happen if, wait, am I looking up negative 1? sorry, I'm supposed to be looking at positive 1 right now. So let's just check that this is possible. If x was positive 1, I'd have 7 minus 2 times positive 1 equals 5. Good, that's a positive width. And I'd have 5 plus 2 times 1, that equals 7. Good, that's a positive length. So x equals 1 is clearly a valid solution. Let's do this again, where this time we're taking our other x value of negative 1.25. That gives me positive 8.5. Good. And the other one, 5 plus 2 times negative 1.25, and that gives me 2.5. So in both cases, I got positive lengths and widths, which are possible, and so that ensures that both of these solutions are valid. Done. Question number 6. We need to solve this equation. Well, as soon as you see this equation, if you don't like factoring and it doesn't tell you to factor, we can just go back into Poly-Samil. So let's do Poly Root Finder. This is a second degree equation. We've already got a 0 on the right side, so we're ready to go. And we'll put in our coefficients. It's 1x squared, negative 5x, and positive 6. And we'll solve, and we're done. X is equal to 3, and x is equal to 2. For those of you who are curious, though, maybe the question could have said solve the equation by factoring, in which case we could factor this trinomial. We're looking for two numbers that multiply to give positive 6 and add to give negative 5. And you'll quickly figure out that those two numbers are negative 2 and negative 3. So if we factored the expression, we get x minus 2, x minus 3, we still have equals 0. According to the zero product property, this means that either x minus 2 is equal to 0 or x minus 3 is equal to 0, and then we end up with the exact same solutions that we found in Poly Root Finder, x equals 2 and x equals 3. Part B, find the coordinates of the points where our graph intersects the x-axis. Now, intersects the x-axis, that's talking about the x-intercept. What's true at an x-intercept? We know that at an x-intercept, y is equal to 0. So 0 is equal to x squared minus 5x plus 6. Hey, this is awfully familiar. We just solved this exact equation. And so clearly we know that our solutions are 3 and 2, so those will be our two x-intercepts at 3 and 2. But it wants the coordinates of the points, and so we're going to have 3, 0 and 2, 0 as your two x-intercepts, the places where the parabola intersects the x-axis. And the last question is number 7. Part of the graph of f is given in this diagram, so we can see that because it's a downwards facing parabola, our a value must be less than 0, so it's a negative number in front of the x squared term. And you can see that indeed we were correct. There's that negative value. Now on this graph, one of the x-intercepts is the point 5, 0. I'm not really sure right now whether the positive 5 is here, or whether the 5 is right there. So let's keep going. I won't add any information to the graph quite yet. Also says that the x-coordinate of the maximum point is 3. Well, here's the maximum. Tells me that the x-coordinate is 3. Oh, well, if 3 is right here, obviously 5 cannot be here, so this one must be 5. Now, due to symmetry in a quadratic graph, if this is a distance of 2 units, well, then this must be a distance of 2 units. So we can quickly figure out then that the other x-intercept must occur when x is equal to 1. Anyway, the question doesn't ask me that at this stage. It says to find the value of b and c if the function is written in this form. So let's figure out first what the value of b is. We can see that the axis of symmetry goes right through the vertex, which means that x is equal to 3 is the axis of symmetry. And we know what to do with an axis of symmetry. We'll write down the equation from the formula booklet. And so the axis of symmetry is 3. Our b value is simply b, so we'll just keep it as a negative b. And our a value is negative 1. Our negatives cancel, multiply both sides by 2, and we'll find that b is equal to 6. Now, in order to find out what the c value is, maybe I can just substitute in one of my known points. So at this stage, I've got that y is equal to negative x squared plus 6x plus c. Let's substitute in a known point, like 5, 0, for example. So when y is 0, x is 5. So 0 is equal to negative 25 plus 30 plus c. Let's put c alone on the right-hand side. That means moving the negative 25 plus 30 to the left. It becomes a positive 25 and a minus 30, and so you figure out that c is equal to negative 5. Alright, tells us now that the domain of f goes from 0 to 6. So our graph is starting when x is equal to 0, and it's finishing when x is equal to 6. They want us to find the range. So, guess we've got to then find out what is the smallest possible value. Well, we know that when x equals 0, our c value, which represents our y-intercept, is at negative 5. So clearly, due to symmetry, wherever I am 3 units to the left of the axis of symmetry, I should be at the exact same place 3 units to the right of the axis of symmetry. And so over here, when x is 6, y will also equal negative 5. Now you can confirm this by substituting 6 into our new complete function, y equals negative x squared plus 6x. Remember, c is now negative 5. So we could substitute x equals 6 and x equals 0 into the function, but you'll see that in both cases you'll end up getting a y value of negative 5. And so our range, y must be greater than negative 5. Okay, says that y is greater than negative 5. Or if you like, negative 5 is less than y. But then y has also got a maximum value. How high up does y go? So why don't we find this y coordinate, and that will show us the highest value of the function. So I'll substitute my x value of 3 into our function, find out what the corresponding value of y is. So I've got 3 squared plus 6 times 3 minus 5, that equals negative 9, plus 18 minus 5. Negative 9 plus 18 is 9, minus 5 equals 4. And so there is the maximum value. And we could have done a lot of this work by graphing our newfound function onto the calculator. So let's just do that. So I'm going to go into y equals, I'll clear this old stuff, and let's put in our function. So we had negative x squared, and then we had plus bx, that's plus 6x, and then we had plus c, where c was negative 5. So plus negative 5 is the same thing as minus 5. And now we can have a look at the graph. Oh, I should adjust my window. Quickest way for me to adjust my window would have been to do zoom 6, right? To go into the standard mode. But if it tells me that the domain goes from 0 to 6, why don't I make the x min 0 and my x max 6? Because I'm only interested in looking at a domain between 0 and 6. Let's choose some more reasonable y values, say from negative 10 up to, say, positive 10. See how we do there. So there's a picture of our graph. We already know that the minimum value occurs at negative 5, but you can check this for yourself. We can say second graph, and we can find out what is the value of the function, option 1. What is the value of the function when x is equal to 0? It tells us that y is equal to negative 5 there, so that's the lowest point. Let's just check on the other side, second graph, second trace, sorry. What is the value of the function, so option 1, when x is equal to 6, the end point of the domain? Again, y is equal to negative 5. So the graph is showing you that the lowest we ever get is negative 5. That's the smallest value in the range. The highest value, of course, occurs at the maximum. We know that x is equal to 3. So second trace, to go into the calculator menu, what is the value of the function, option 1, when x is equal to 3? And you can see that the highest y ever gets is 4. And that is why our range goes all the way up to a maximum of 4. And I think that's it for the questions. Yes, we're done. So good luck studying, and we'll see you for the test.